Okay, welcome to Chem 2. This video is going to show you some of the math and the reasoning behind it for Chem 2 with moles. So anyway, in the mole unit, we're going to be using conversion factors to change from one unit to another unit. And here, there are four here, and these two down here are when you're dealing with solutions. Anyway, so I'm going to kind of show you how this works. But to show you, I'm going to work with something that you're more familiar with or start off with, and that's time. Now, the key is what we want you to learn is how to do this dimension analysis. Okay? Anyway, so here's an example. How many minutes are in 360 seconds? Well, the first step when you do use dimension analysis is to write down what the problem gives you, 360 seconds. All right, so you write that down. Now we're going to use these math symbols. We call it picket fence. The vertical line means multiply. The horizontal line means divide. All right. Now after we write that 360 seconds down, we have to find a conversion factor that will let us change from seconds to minutes. So we have to go up here and find the correct conversion factor. Now here's a big clue. When looking for a conversion factor, you have to look at this unit right here, which is seconds. You have to pick a conversion factor that has seconds in it. So I look and I'm like, this one, no, this one, no, this one, yes, it has seconds. Now the next critical thing with dimensional analysis is one of these numbers in the conversion factor is going to go on the top and one's going to go on the bottom. And here's how you always know. The units have to go diagonal, have to be the same. So like 360 seconds, this 60 seconds will go on the bottom, and then the 1 minute will go on the top. Now, I got a made-up term I use for this. I call it the principle of diagonality. If you have whatever unit you have here, the same unit diagonal going this way, right there, that has to be the same unit. Then I would do the math. 360 times 1 divided by 60, and that ends up equaling 6 minutes. Now, the picket fence, I could have written it like this, 360 seconds, and I could have put it in parentheses, and then I could have multiplied it by 1 minute over 60 seconds. So maybe in math class you're used to seeing these parentheses. Using the picket fence is just kind of a faster way of using parentheses. You can think of like this being a parenthesis here. It's just a faster way of drawing it. Okay, number 2. How many hours are in 27 days? Step 1 always in this unit is to write down what the problem gives you. 27 days. Draw the picket fence. And then we're going to look for a conversion factor that works. And so we look, and this one minute to seconds. No, see, we need one with days. So we look and we find this one has days in it. All right, that's the conversion factor we need. Now, which one goes on the bottom? Where does days go, on the top or on the bottom? Well, follow the principle of diagonality. 1 day and then 24 hours will go at the top. So you would take 27 times 24 divided by 1. That equals 648 hours. Okay, number 3. How many seconds are in 3 hours? So we write down 3 hours. We always write down what the problem gives you. Draw the picket fence. Okay, now we have hours, we're going to seconds. So we go up here and we see, and this is where things can get a little more difficult. We have to have something with hours down here. So we look, and here we have an hour one here, and we have an hour one here. But we want to go to seconds. Unfortunately, there's no conversion factor that goes directly from hours to seconds. And this is where you got to use your brain and say, hey, I can't really convert hours to seconds in one step, but I could convert hours to minutes, and then I could convert minutes to seconds. And so what you would do is you would choose this conversion factor right here and put in the 1 hour here and the 60 minutes here, and just keep on going. Don't stop. Don't stop and do this problem and then do another one. Just keep on going. And now we have minutes here, and we want to go to seconds. So now we got to look for a conversion factor that has minutes to seconds in it, and here we see the top one right here that has 1 minute. Notice how my units are diagonal, going this way every time. 1 minute, and that equals 60 seconds here. See, the units will always be diagonal. That way they cancel out, leaving you with the unit that you want. And so if you do the math, I think it equals something like 10,800 seconds. All right? Okay, now I just wanted to show you a couple mole ones. Now with moles, we're going to use these conversion factors right here. We have 1, 2, 3, 4, 5, 6. Those are the 6 that we're going to use. You have to use the numbers that go with these conversion factors. Let me show you. Number 1, how many atoms are in 5 moles of iron metal? Step number 1, write down 5 moles. Now, in chemistry, abbreviate the word moles with just MOL, in case you're wondering. So 5 moles Fe. Draw the picket fence. Now, we know we have moles, so down here we have to have moles. But we want to go to atoms. So if we look at our conversion factor, we see conversion factor 1 has moles, so we could choose that one. Number 2 has moles, and number 3 has moles. The rest of these don't have moles in them, so we're not going to pick them. All right, so, but now we want to find the one that has moles to do atoms. And so we look, this one right here has moles to atoms. And so it's 1 mole. See, the number 1 goes with the unit mole. You got to make sure you do that. And then this Avogadro's number, 6.02 e to the 23rd atoms, is the other part of the conversion factor. So you would take 5, and then you would take that times 6.02 e to the 23rd, and you would get something like 3.01 e to the 24th atoms. Okay, let's do another one. Number 2, how many moles are in 6 liters of oxygen gas? So 6 liters O2. We draw the picket fence. Now we have liters here, we have to have liters here. So if we scan all these things, we see that we have liters here, and we have a gas at STP, gas at STP. That means we're going to use this one. We wouldn't use this one down here because this is for solutions, like things with water in them. Okay, this is a gas here, okay? So we're going to use this conversion factor right here. Now, we got 22.4 liters in 1 mole. The principle of diagonality, liter here, we have to put our liters there. Notice that the 22.4 goes with the unit liters, and the 1 mole goes up here. So then we would do the math. 6 times 1 divided by 22.4. That equals 0.27 moles of O2. All right, here's another one. How many moles are in 500 milliliters of a 3 molar solution? Okay, now this problem is a pretty hard one, and we're not going to start off with this, but I just want to show you how it would work. Okay, this is called the molarity. That's what that capital M stands for. And that's a term you'll get familiar with in this class. But anyway, we're going to start down. Whenever we get a problem like this, you're always going to write down how much you start with, 500 milliliters. So whenever you have a solution and you're trying to find moles or grams or something, always write down how much solution you have. That's where you're going to start. Now, this is, whenever you see a molarity, that tells you have a solution. Now, we have to pick which one of these we need. We have milliliters here, so we got to pick the one with milliliters here. That's 1,000 milliliters goes down there. And then what's going to go on the top? The molarity, which is 3. And that 3, capital M, means 3 moles per 1,000 milliliters. So you would just write 3 moles there. And so 500 times 3 divided by 1,000, and that equals 1.5 moles of NaCl. Okay, last one. How many oxygen molecules are in 3 liters of oxygen gas? Always write down what the problem gives you. Okay, so we got 3 liters of oxygen. And anyway, we got liters here, and it's a gas at STP. So that means we're going to use this conversion factor right there. If we got liters here, we have to put liters down here. And then if we write that, the opposite side of the equal sign goes on the top. All right. Okay, but here we have a problem. It says how many oxygen molecules. Right now we're in moles. So we change from liters to moles. But we don't want moles, we want molecules. Somehow we got to change from moles to molecules. And so if we go back up and look at conversion factor number 1, we see that it has moles and molecules in it. We have moles here, we have to have moles here. We look, 1 mole O2 and the 6.02 e to the 23rd molecules goes up here. The 6.02 e to the 23rd can either go with an atom, molecule, or formula unit. It depends what you're given. O2 is not an atom. It's 2 atoms hooked together, and it makes what's called a molecule. So that's why we would call O2 a molecule, because it's just not a single atom. All right, then you would do the math, and you would get 8.1 e to the 22nd molecules. Now, one last thing. Some people might wonder about what's this E business, what's this stand for? Okay, well, 8.1, you could write it like this, 8.1 times 10 upper caret 22nd power. It's scientific notation, and it's really important to bring your calculator to class as soon as possible because we need to show you how to enter these E values into your calculator. Really, really important. Bring a calculator so you can learn how to enter that in. Okay? All right, that's it for this video.